So example 8.23 is ideally only a 3-mark question. It will be a part of your section B. So this is a second order linear differential equation, right? So whenever you have a second order linear differential equation, the procedure to find it is as follows. You have to find the characteristic equation. To find the characteristic equation, you substitute, instead of d you just say p squared plus 6p plus 9 equals. So how do we solve this p squared plus 6p plus 9, right? So somewhere in your 8th or 7th standard or 9th standard, you would have learnt about the sum and product method. Do you remember? Right? How do you get the sum? Right? This middle term here would be the sum, right? And the product will be this 9 into coefficient of p squared, which is 1, right? So how can I write 9 as 3 into 3? And using the same 2 3's, I can write it as 3 plus 3 is also 6, right? So I can write this equation as p squared. The 6p I will split it as 3p plus 3p plus 9 equal to 0. Many of you will be familiar with this, so you can do it straight away, but I'm just explaining it for someone who doesn't know about this. Plus, if you take this term here, you can take, which is common here, 3 is common, so p plus 3 equal to 0. So now this equation can be written as p plus 3 into p plus 3 is equal to 0. Or in other terms, this is nothing but p plus 3 the whole squared equal to 0, right? So obviously when you saw the equation p squared plus 6p plus 9, you should also be able to associate it with p plus 3 the whole square, because it comes with a plus b the whole squared formula, a squared plus 2ab plus b squared. But if you're not able to identify in that way, you can use the sum and product method to find out what are the values of p. Okay, so we get p is equal to minus 3 comma minus 3, right? So when we see that the roots in the characteristic equation are the same, right, then the solution would be, okay, that is a CF. The common factor would be ax plus b into e power minus 3x. Suppose you had two different values here, then the formula will be different. We'll see that later. Therefore, we can write the solution as y is equal to ax plus b into e power minus 3x. So which is your final solution. So you just have to write the characteristic equation, which is, instead of d squared here, put it as p, and solve it using the sum and product method. And since both the roots are the same, this will be the formula, ax plus b into e power minus whatever you got the root as, and a and b are arbitrary constants. So this is a very, very easy 3-mark question.